Hello, this is the Daily Space for today, Friday, November 24th, 2020. I am your host, Beth Johnson, and I am here to put planetary science in your brain. I hope all of our friends in the US had a lovely Thanksgiving under the circumstances. I personally enjoyed dinner with my husband, son, and our best friend. I baked pumpkin pies, and we had prime rib and all the sides. Then we watched cheesy Christmas romance movies because we all need some happiness and cheer. So, to those of you taking the time to tune in today, we thank you. Pamela has said it a few times this week, but I want to express my own thanks for all your support and kindness. Thank you. Now for the planetary news of the week. Our first story of the day comes from our very own Planetary Science Institute, and it is fresh off the press release list. For once, we're going to talk about the science behind a comet and not just whether or not it will become a naked eye wonder. Let's start with some background information. When I was working as an intern, I learned that there were basically two types of comets, long period comets and Jupiter family comets. Long period comets orbit the sun on the scale of 200 or more years. Jupiter family comets orbit the sun from inside the orbit of Jupiter. Then I learned there were also short period comets that orbit from the Kuiper belt inward to Jupiter. There's another type of object, though, that falls somewhere into the cometary category, however. They're called centaurs. The press release explains centaurs are icy bodies in unstable orbits between Jupiter and Neptune and cross the orbits of one or more of the giant planets in their journey around the sun. The gravity of these planets provide rapid dynamical evolution of the objects and either eject them from the solar system entirely or cause them to eventually evolve inward of Jupiter to become Jupiter family comets. Prior to this migration, centaurs began as objects beyond the orbit of Neptune, whose gravitational tugs caused the object to slowly leak into the centaur population. This entire migration from beyond Neptune to Jupiter family comet lasts a few million to a few tens of millions of years. And here is where today's press release gets interesting. Observers using the Atlas telescopes found comet L 2019 LD2 last year, and it is in the process of transitioning from a Centaur into a Jupiter family comet, a process we have never witnessed before. Lead author Jordan Steckloff says, we find that 2019 LD2 is currently in the vicinity of a dynamical gateway that facilitates the majority of transitions from the Centaur population into the Jupiter family of comets. The dynamical gateway is a region beyond Jupiter, extending to just inside of Saturn's influence. Steckloff goes on to explain, most significantly, our work found that LD2 is most likely a pristine comet. Although it has likely lost some supervolatile ices, such as carbon dioxide ice, in the outer solar system beyond Jupiter, it is unlikely to have ever been in the inner solar system, which is warm enough for water ice to sublimate. This means that LD2 is a pristine comet and presents a unique opportunity to observe how pristine Jupiter family comets behave as their water ice begins to sublime for the first time and drive comet activity. Moreover, this transition is likely to finish in only 40 years from now, which is a blink of an eye for astronomy. This means that people alive today will be able to follow this object all the way through its transition into the Jupiter family comet population. 40 years. Astronomical events usually happen on astronomical timescales, but I might even still be alive to see that transition finish, which is amazing. This research on this one small body might help answer important questions about solar system evolution, such as why we have active comets and inactive asteroids, and how they change definition. Planetary scientists love to categorize objects, and we need to understand the categories fully and the bodies we place within those boxes. This article was published in Astrophysical Journal Letters and is very interesting to me. We're hoping to have Dr. Steckloff on the Daily Space next week, so please stay tuned. Slightly closer to home, Mars is making news again. I mean, when isn't Mars making news these days? This time, field geologists have analyzed data taken from Curiosity at Gale Crater and determined that a megaflood occurred in ancient Martian history. In a paper published in Nature Scientific Reports, researchers explain how this megaflood left behind familiar ripple structures in the crater that match ones we have on Earth. The flood was likely set off by a large meteor impact about 4 billion years ago that unleashed massive amounts of ice stored in the subsurface of the red planet. According to lead author Ezet Hadari, this case includes the occurrence of giant wave-shaped features in sedimentary layers of Gale crater, often called megaripples or antidunes, that are about 30 feet high and spaced about 450 feet apart. These features match antidunes formed by melting ice here on Earth around 2 million years ago. Per the press release, the most likely cause of the Mars flooding was the melting of ice from heat generated by a large impact, which released carbon dioxide and methane from the planet's frozen reservoirs. The water vapor and release of gases combined to produce a short period of warm and wet conditions on the red planet. Condensation formed water vapor clouds, which in turn created torrential rain, possibly planet-wide. That water entered Gale crater, then combined with water coming down from Mount Sharp to produce gigantic flash floods. It's generally accepted that Mars had water in the past, and that has led a lot of us to think life was once possible. All we can really do now is wait for perseverance to arrive and see if it finds what we're hoping for, evidence of that past life. From Mars, we move even closer to home and take a look at Earth's latest minimoon, a newly discovered asteroid with the designation 2020 CD3. Astronomers used the Lowell Discovery Telescope to analyze this second minimoon, and their work is published in the Astronomical Journal. A minimoon is a tiny asteroid that gets captured by Earth's gravity, orbits our planet for a while, and then gets flung back out into the solar system. The first minimoon discovered here was found back in 2006. CD3 was discovered early this year, and scientists quickly rallied to observe and understand our new satellite while they had the chance. Measurements indicate that CD3 is a natural satellite made of silicate, about 1 to 1.5 meters in diameter, size of a small car, and that it came within about 13,000 kilometers of Earth. While this is only the second mini-moon found, the expectation in the astronomical community is that we will find more of these small transient bodies once the Rubin Observatory is complete. Again, understanding mini-moons will help understand the evolution of our solar system and possibly even provide targets for robotic exploration. That sounds kind of cool to me. This has been The Daily Space.